Hello everyone, we are going to discuss about deep learning, that is part 2. I have already given part 1. If you want, please go through that, and we'll continue with the next topic. The topic name is gradient descent. Gradient descent is an optimization algorithm. So the name gradient descent is the name of an algorithm, which is an optimization algorithm for finding a local minimum of a differential function. So this algorithm is used for finding a local minimum of a differentiable function. Gradient descent is simply used to find the values of a function's parameters and that minimize a cost function as far as possible. So gradient descent optimization algorithm is simply used to find the values of a function's parameters that minimize a cost function as far as possible. Okay, so this is the usage of gradient descent algorithm. Next, most machine learning and deep learning algorithms involve some sort of optimization. So optimization refers to the process of either minimizing or maximizing some function by altering its parameters. Next, with gradient descent algorithm, you start with a const function, also known as loss or error function. So gradient descent algorithm, with this algorithm, we will start with a cost function. The function name can also be called as loss function or error function based on a set of parameters. The goal is to find the parameter values that minimize the cost function. Here is the picture where you can understand the cost function, local minima and global minima. So we'll discuss about this picture. How can we gradient descent? In the topic gradient descent, we'll have some more discussion. How can we avoid local minima and always try and get the maximum weights based on global minima? So different types of gradient descents are there. So batch gradient descent, stochastic gradient descent, and mini batch gradient descent. These are the three different gradient descents. In batch gradient, we use the entire data set to compute the gradient of the cost function for each iteration of the gradient descent and then update the weights. So in batch gradient, what we will see, we use the entire data set. The data set is the data which is used in the algorithm, which is useful for the algorithm. The data set contains all the useful data which will be useful for the algorithm. So we use the entire data set to compute the gradient of the cost function. So we are going to compute the gradient of the cost function for each iteration of the gradient descent and then update the weights. So this is the process of batch gradient. So since we use the entire data set to compute the gradient, convergence is slow. Since we use the entire data set, To compute the gradient convergence is slow. If the dataset is huge and contains millions or billions of data points, then it is memory as well as computational intensive. Stochastic gradient descent. The second, in stochastic gradient descent, we use a single data point or example to calculate the gradient and update the weights with every iteration. We first need to shuffle the data set so that we get a completely randomized data set. As the data set is randomized and weights are updated for each single example, update of the weights and the cost function will be noisy, jumping all over the place. Mini batch gradient descent. So the third one here, mini batch gradient descent is a variation of stochastic gradient descent, where instead of single training example, mini batch of samples is used. Mini batch gradient descent is widely used and converges faster and is more stable. Batch size can vary depending on the data set. As we take a batch with different samples, it reduces the noise, which is variance of the weight updates, and that helps to have a more stable convergence faster. We'll see about regularization. Regularization is one of the most important concepts of machine learning. It is a technique to prevent the model from overfitting by adding extra information to it. Sometimes the machine learning model performs well with the training data but does not perform well with the testing data. It means the model is not able to predict the output when deals with unseen data by introducing noise in the output, and hence the model is called overfitted. When will be the model will be called as overfitted? The model which is not able to predict the output, in such case the model is called overfitted. This problem can be dealt with the help of a regularization technique. So this technique can be used in such a way that it will allow to maintain all the variables or features in the model by reducing the magnitude of the variables. Hence it maintains accuracy as well as a generalization of the model. It mainly regularizes or reduces the coefficient of features towards 0. In simple words, in regularization technique, we reduce the magnitude of the features by keeping the same number of features. Types of regularization. Ridge regularization. Types of regularization. So ridge regression, lasso regression, we will talk about this. Ridge regression is one of the types of linear regression in which a small amount of bias is introduced so that we can get better long-term predictions. Ridge regression is a regularization technique. Okay, this which is used to reduce the complexity of the model. It is also called as L2 regularization. Now coming to the next topic, lasso regression. It is an It is another regression technique to reduce the complexity of the model. It stands for least absolute and selection operator. Lasso regression is nothing but least absolute and selection operator. It is similar to the ridge regression except that the penalty term contains only the absolute weights instead of a square of weights. It is also called as L1 regression. So with this we complete the topics in this video. So thank you all.